Thank you very much, Thibault, for the introductions, and I would like again to thank you for inviting me for this conference. So, as Thibault mentioned, my work is more on the base aspect of fruit ripening. I do grape genomics, but I will try to not to bother you today with genes and all these different things. And rather, I decided to actually shape the presentation in something that you observe every year in your field, and try to come up with some tentative answers about these different events. So, okay, so my research topics basically is to look at understanding the molecular mechanisms that are mostly associated with the control of grape ripening and the impact of environmental factors. So if we go to basically the growth of a fruit, it's kind of common to every fruit. A fruit will go to different phases: fruit sets, growth, and ripening. And in these different phases, a lot of genes and metabolites will be actually activated to facilitate the transition from one phase to another. And so I want you to see that actually we are going to talk something that so far is kind of very poorly understood, which is basically what is happening during what we call the fruit maturations. I'm not talking about fruit maturity, but fruit maturations, something that is going to basically is going to facilitate the fruit to enter into the ripening phase. So all these different transitions basically are triggered by different signals that could be actually some endogenous signal or exogenous signals. So exogenous signal would be actually environmental factors, heat, light, and anything else. And all these different signals will actually trigger a lot of cascade of events in the fruits that will basically facilitate the transition of this different phase across the fruit development, from the berry formation, ripening process, and finally the fruit maturity. So basically, I think it is very important in terms of basic research to have a better understanding of what actually controls the ripening, because in that sense, if you know how to actually have a better understanding of the control of ripening, you can improve the fruit quality. And in the future years, in light of climate change, having actually a better understanding of the control of ripening could be actually a very nice tool to basically identify new genetic materials that are suitable for any kind of climate. So, and again, in terms of gene discovery, a better understanding between relationship between genes and traits is also another very important aspect to actually improve some trait of interest like color or berry flavor or mouthfeel. So, and the need of having this understanding will actually lead to selection of some genes to better understand actually the interactions between environment and genes. So, as I said, I'm very interested in this major scientific goal, which is actually to identify genes that control the ripening process, and how actually environmental factors could actually alter or promote their action. The thing is, grapeberry or a cluster is not an easy model to track. We're not talking about actually a single fruit, but rather a population of fruits that develop at their own pace, leading to actually the concept of sinc strength. So, but something that is interesting in this model is basically something that a few people are looking at, is actually this variability you observe in the clusters, where you are going to see actually some berries that are more advanced in the ripening and others that are actually lagging. So we have delayed and advanced berries. So, and maybe through this prism, through this angle, we can actually better understand the control of ripening. So the idea is to using this model of uneven ripening that you observe every time, especially at the raisins, to actually identify genes that are responsible to delay or to advance the ripening. So based on that, we came up with actually a different set of projects. And we started to understand actually what causes this variability you observe in the field. And we started from the beginning with actually here an uneven flowering events during the bloom, and how this could lead to actually a huge variability when you look at a cluster during berry maturation, and leading to this aspect of, I should go here too, right? To actually the uneven ripening. But what you know also is actually after that times, the variability and the variations tends to mitigate towards the maturity. So we designed actually 3 different projects to see what could explain this trait and try to come up with some tentative answers. So the first project was focused on actually on better understanding if you have a linear correlation between actually uneven flowering that happens in inflorescence and the uneven ripening you observe at veraisons. So we use as a proxy for veraisons, because veraisons span over maybe 2 weeks. We took as a fixed stage, we took the mid-veraisons, where you have 50% of your berry are still lagging compared to the other. The second project was mostly looking at what I mentioned at the beginning, the maturation phase. What happens at that time that leads to actually this uneven ripening you observe at the ripening onset. And the third project, what is the fate of this uneven ripening? Okay, everybody thinks that actually everything is settled down until the end, and all this variability is kind of disappearing. But we have very few or even no data about that. Okay. So the first project, as I mentioned, the idea was to do an experiment in the field and to try if we could have these relations existing. Does actually kind of, it comes down actually to these questions. Does early flower, blooming, or more advanced berries? What's that? Oh, okay. What are more advanced berries? So in that case, what we did is we tagged the berries, the flowers. We tagged the flowers with some color-coded, and we tried to correct, depending on the color of the strings, if you are in relation with the ripening stage. And we monitor also some other aspect, berry size, berry weight. Here on the left panels, what you have is something that we could see actually kind of what everybody believes, that early flowering somehow are going to give you actually a greater proportions of more advanced berries. So in this panel, you have the day of anthesis versus the percentage of berries that emerge for each of these days of anthesis. But I want to stress out these 2 circles here. It looks like that even in early flowering, you have some events, so you have some berries that are still green. And on the opposite sides, same thing here with the late flowering. Some berries are still more advanced. So the relation between flowering and ripening is not as intuitive. And when we look at actually over parameters, when you look at the sugar, for example, you can see that in each of these different berry classes, the sugar level seems to actually not to be affected by the flowering time. You have exactly the same level of sugar within each class. So we did different measurements, and where we came up also with this ratio here, we tried to see actually if seed could actually contribute to these patterns. And what we found, not the seed weight, but the seed weight related to the berry weight seems to also be strongly related to the ripening stage at mid-veraisons. So seed weight to berry weight. I will put the acronym SB for the rest of the presentations. So basically, the weight occupied by the seed appears to be strongly correlated to the ripeness of mid-veraison berries. So we came up with actually a model that tried to combine the different aspects of flowering times and seed weight to berry. And in this model, basically, depending on where you are, early flowering or late flowerings, the seed weight to berry seems to actually have a huge impact on explaining why a berry is green, pink, or red at mid-veraison. Oops, sorry. So based on that, we came up with actually a second project to look at actually in more focused way what happens at the berry maturations and how we come up with actually these uneven patterns. So there is different evidence from the literature that seed impact fruit growth, and seed is not actually to send some hormone signals to the fruit, especially in strawberry, but also in tomato, and especially one hormone, the auxins, And it is known that actually during that stage, at the berry maturations, embryo growth and differentiations of the embryo happens in the seeds that could actually might supply the pericarp in plant growth regulator. So we came up with a second study and try as a step one to better understand the relationship between seed weight to berry weight and ripening classes at mid-verisons. And here you have, on the left panel, you have actually a bivariate analysis showing each individual berries and the relation between seed weight to berry weight and their ripening classes. And in that case, as you can see, that depending on the range of the seed weight to berry weight, you have a very contrasting patterns that can be seen here, where in the berry population with low SB, you have mostly basically advanced berries, while in the high SB, you have basically green berries. So, yes, here. Here, so low SB, mostly advanced berries, high SB, green berries. So, it looks like that actually the range of seed berries seems to be associated with the nature of the berry class you observe at mid-verisons. So the second step was actually to determine between the relation between SB and ripening classes during the ripening stage. And what we observe on this panel here, that these differences could be actually traced down back to actually 2 weeks before the first sign of ripening. So this difference already exists 2 weeks before during the berry maturations. As you can see here, you have clear differences between the population of berries with low SB versus high. And when we try to correlate that to actually a ripening aspect, you can see that when we look at the sugar, comparing actually low SB and high SB, 2 weeks before actually the verisons, the sugar level in the two classes are kind of the same, but they tend to diverge once we reach 1 week before verisons, and you start actually to see the divergence between the berry classes. And when you arrive at mid-verisons, you have your purple berries and you have your green berries. Okay, go there. Here. So you can see actually the divergence in the sugar accumulations across the two berry classes. So we try to correlate that actually to hormone contents. And what we observe is basically when we look at the hormone contents of auxin in the different tissues at maturations and during the ripening initiations, basically the seed is a massive reservoir of auxins. You can see that in the black bar, this is the level, the content of auxins at different stage of the ripening initiations and during the berry maturations, compared to the other two tissues that do not contain so much in auxins. So we have seed, weight to berry weight, ripening class, and seed is a massive reservoir of auxins. So now let's see what is the level of auxins in these different berry classes, either with low seed weight to berry weight or high seed weight to berry weight. And when we did this during the maturations, what we observed actually a clear differences at least 1 week before verisons between low and high. Here. Where is my pointer? I think it just died. So on the right side of your panel, you have the difference basically. Okay? So, and auxin is known to actually delay the ripening. Yes, I know the time. Don't worry. So we have this aspect. So basically, auxin level seems to be in the pericarp tissue seems to have different level 1 week before the ripening onset. So the measure outcomes that we can actually draw from that, the difference in auxin level in the pericarp of low and high SB begin to emerge prior to the ripening onset. Okay? And this could be actually associated with the seed contents, and auxin could be actually exported from the seed to the pericarp. An earlier decrease in the low SB berries might explain why these populations of berries enter into the ripening earlier. Okay? So we come down with actually the third project. What is the fate of these berries when they go to the maturity? So in the same things, we try to monitor these different berry classes. And this is what we did here. We just, same thing, we tagged the berries at mid-verizons, and we try to see their fate in terms of ripening, but we went to actually some gene expression level. So this is on the left side of the lower panel, a PC analysis looking at sugar, pigment, and elasticity. So each dot here represents actually an individual berries. And you can see that at mid-verizon, of course, you can easily segregate the different berry classes. But when you come down to actually to the maturity stage, 5 weeks later, all these different individual berries are mixed together. So basically, individual berries lose their respective ripening classes by the time they reach maturity. So we use new technology to look at actually what's going on in terms of gene expressions. And we use whole genome arrays and are able to measure basically the 30,000 genes that are present in the grape genome. So, and we did comparative analysis by looking at the expression level at mid-verizons versus at maturity. So I'm not going to go into detail with the genes, but just looking at the numbers. So here in each tissue, when we compare actually these 3 berry classes at mid-verizons, you have in the pulp, in the skin, in the seeds, around 3,000 genes that are differentially expressed between the green, the pink, and the red. When we go down to maturity with the same classes, basically you have basically 2, 5, and 5 genes. So you have basically a huge dramatic reductions in the number of genes that are expressed differentially from the mid-verizon to harvest. So what does it mean? That means somehow they are settled down. So how does it work? How does it settle down? Basically, we came up with this and tried to better understand actually the enhancement, why the greens basically are catching up. And in that case, the idea is to look at actually those different berry classes when they are reach equivalent ripening stages. And when we did this, basically what we observe in the lower panel, the green berries tend to accumulate more sugar than the red berries when the green berries have reached an equivalent ripening stage, which occur basically 2 weeks after the moment they have reached a red soft stage. So you have an enhancement in those berries, okay, in terms of pigment, in terms of sugar. So here is the conclusion here for the project 3. We have an existence of mechanisms that we call berry synchronizations and the gene expressions. The lagging berry seems to hasten the ripening when they reach a red soft stage, suggesting changes in zinc strength. The lagging berries that were basically with high seed weight to berry weight and more auxins, initially delayed during the ripening stage, but happens to be actually the same berry that enhance their rate at the end. So that is a very interesting point, that linking actually berry maturation, what's going on during the berry maturation, and its impact on the berry ripening process later. So if we go to the overall conclusions, the major outcomes is flowering time is not a major direct contributing factor of the ripening asynchrony in grapes. Basically, seed mass relative to berry weight correlate to the auxin level in the pericarp of ripening at pre-ripening stage, delaying the ripening process. But it happens that actually those laggers tend to actually speed up their ripening process later on to facilitate a more uniform ripening later on. So the current perspective, does the flowering, this is the last one. Does the flowering times influence seed content? That is a very interesting question. If we admit there is a communication between actually the seed and the pericarp, how does it work and when? And basically, if we look at actually the berry synchronization aspect, what is the regulatory nature of these mechanisms? Because actually it could help to better understand what does delay or what does enhance the ripening process in grapes. And I'm done.